What's up, calculus students? Let's get into it with the natural log function, whose slope equation is just reciprocal of its x value. Lots of different questions here, but they all are just the same thing, just kind of reminding you how instantaneous rate of change is the same as the slope of the tangent is the same as the derivative. Maybe we'll write a statement acknowledging we know what we're doing. Constants, you don't need to use the product rule. This would be the slopes of 3 log x at x. This would be the slope at 2. What does this mean? At x equals 2, f of x is increasing 3/2 of a y per x. Why do we say increasing? Because the slope is positive. You got a fraction. Don't freak out. Yeah, no problem. That's the slope at x. This is the slope of f at 3. It's 1/9 at x equals 3. F of x is increasing 1/9 of a y per x. It's going up 1/9 of a y per x, so slowly. So slope of the tangent, same question. Now we see our first instance of a chain, but it's very interesting, the log function and how it behaves, and how you'd think log 2x would be at a different rate. Remember, the log parentheses derivative is 1 over parentheses, so we would use the chain rule with an O and an I, and we get 1 over 2x times 2. Whatever starts in the parentheses stays in the parentheses. We can write it like this, but what I kind of told you in class is that if you have a fraction times 2, that 2 goes in the numerator. It's like 2 over 1. So I could have written it just like this, and then I could realize, since we have multiplication, that we can simplify. And the slopes of log 2x are actually the same as the slopes of log x. So the slope of f at 4 is just 1/4. But most times we will have something different. We will have to use rules, and they will produce things that are different. So just follow your rules, whether it's the product rule. Now plug in e squared now, because I know that this is the same as x over x, which is the same as 1. So I just have log x plus 1. And then plugging in e squared, don't forget the natural log of e squared is just 2, the number 2. I'd get 3. Is f of x increasing or decreasing at the given value? Very good question. Well, if we knew the slope at e, if it was positive, it's increasing. If it was negative, it's decreasing. So maybe we're just gonna find the slope and then have the statement, and then in the statement we say increasing or decreasing. Many of you are probably thinking we need to do a full sign analysis, but again, just like in the last lesson, if you're only asked if we're increasing or decreasing at a value, we don't have to do a full sign analysis. We could just do the slope at that value. We use the quotient rule here. This is a very common one we're going to look at. Going to simplify e. Well, this is a bad question. Changed it. Heads up, changed it. If you're skimming through, I changed it. Okay, natural log of e squared is 2. So I have 1 minus 2 over e to the 4th. That's negative 1 over e to the 4th. This is negative. So we would say h is decreasing e fourth y per x at x equals e squared. Chain rule, OI, multiply it together, that 4x cubed would go up here. What starts in the parentheses stays in the parentheses. We realize that can be simplified if we want to. Slope at 2 is 2, 4 over 2 is 2, which tells me r is increasing 2 y's per x at x equals 2. There's a different O and I. So we haven't seen anything crazy yet, guys. And we did one example in class. I was like, kind of tricky. This one is, these are not as tricky. If I plugged in 1, I probably should have plugged in like e to the negative first or something. But if you plug in 1, you get 3 natural log of 1 squared times 1 over 1. Team, the natural log of 1 is 0. This is something you are required to know and understand, that the natural log of 1 is 0. Why is that? Because the natural log of e to the 0 would be 0, and e to the 0 is just 1. So remember that. So this slope is 0, and you would say that the function is constant or it's flattened out. M is neither increasing nor decreasing. M is constant. I love this one. Why do I like this one? Watch what's going to happen. 1 over parentheses, cosines, slopes are negative sign. Multiply them together. Negative sine x over cos x, which is negative tangent x. So the slope of q at pi over 3 is the negative tangent of pi over 3. Tangent of pi over 3 is root 3 over 2 divided by a half, which is root 3, so it's going to be negative root 3. That means q is decreasing root 3 y's per x. All right, I want equations of tangents, so I need y values and m's. Using the x values. Look at that one. All right, cool. Six is the slope. 0 is the y coordinate. That's from getting 1 and plugging in there. And you get the log of 1, which is 0. Natural log of 2 is the y value. We don't know the natural log of any other number besides e's to powers. So we don't know the natural log of 3, but we know the natural log of e cubed is 3. So that's one thing. When finding the slope equation using the chain rule, we get -1 over 1 minus x. If I plug in -1, I get -1 over 1 minus -1, which is 2. So I get -1/2. My function is decreasing by that many y's per x. Ooh, what is gonna go on here? I got 1 over times 1 over x. If you multiply these two together, 1 over parentheses times 1 over x, we would get a slope equation that would be 1 over log x times x, or 1 over x log x. You're not allowed to multiply the x by the log x. That's what started in parentheses, so it's not log x squared, it's just x log x. If I plugged in e, get 1 over e times the natural log of e, which is 1. So that's the slope 1 over e. And what is f of e? Well, the natural log of e would be the natural log of 1, which would be 0 again. Find the second derivative of f at e, and what does it tell you? Great question. I got another o and I. The o is 1/2, parentheses squared. The I is log x. So I'd get really just the first power. The 2 would come down, multiply by the half, and be a 1. Subtract 1. That's the power rule. This is 1 over x. What starts in the parentheses stays in the parentheses. So f prime would be, if I multiplied this 1 over x, I'd get log x over x. Okay. Now if I were to take that derivative and get the slopes of my slopes, get the slopes of the top times the bottom, minus the slopes of the bottom times the top, all over the bottom squared. That's 1 minus log x over x squared. We've done that one before. And if I plug in e cubed, what happens? I get 1 minus 3, which is -2. E cubed squared is e to the 6th. What does that tell me? It tells me the slope of f prime. Tells me f prime is decreasing by 2 over e6y per x. Okay, because you know the slopes of the slopes. It also tells me that since the second derivative is negative, the original function must be concave down. And that's what we're looking for. Since my second derivative is negative, my original function is concave down, or my first derivative must be decreasing. Well, we have to do the chain rule for both of these separate. Many of you probably don't need to show those work, but if you do, it's great, and you probably won't make mistakes. If you don't, more likely to make mistakes until you really know what you're doing. So I already have the first derivative. That's already y prime. So the second derivative, again, the notation for the second derivative is this. You need to be familiar with that. Would be 2 cos 2x. That's the first one. And then I'd minus 3 over 3x. Well, that simplifies to just be 1 over x. Now, if I were to look at that and find the slopes of that, you would O and I this. I'd have 2 cos, I'd have 2x. I'd get -2 sine, cosine slopes are negative sine, and then another 2, give me -4 sine 2x. And what are the slopes of 1 over x? This is a great question. What's the derivative of 1 over x? Well, you could use the quotient rule, but if you're taking the slopes of the top, it's 0 times the bottom minus the slopes of the bottom times the top over the bottom squared. You get -1 over x squared. Or, hopefully you remember that 1 over x is the same as x to the negative first, and the slope should be -1 x to the negative second, which means you add the opposite, -4 sine 2x plus 1 over x squared. Okay. To ensure a function is continuous, we just got to make sure the y values to the left and the right of the important x value equal each other. Well, if I'm plugging in 0.99999, plugging it into the top. If you plug that in, you're going to get something that approaches what you get when you plug in 1. We've done this before, but we're just reviewing. So you're essentially just plugging in 1 to the top and the bottom, so you get them equal to each other. You need to know the natural log of 1 is 0. You get b is 3. Because you know the natural log of 1 is 0. Same thing here. I get 2a over e times e minus 3 equals 4 log e plus 2. These e's cancel, giving me 2a minus 3. This is 6. 2a equals 9. A equals 9 halves. My a's and my 9's look really similar, and I apologize for that. That looks like a Q. Whatever. Should just do capital A's. I'm not gonna do it quickly. I'm just gonna do it quickly. A e to the log 3 equals 4 over log 3 plus 2. E to the log 3 is 3. 3a equals 6. A equals 2. Cool. All right, so continuity, piecewise functions. Differentiability, piecewise functions. What do we have to make sure? Not only do the pieces meet up, but they meet up smoothly, so that there's no sharp points. I know everybody thinks like sharp points are bad. It's like, don't assume sharp points are bad. Some of us made mistakes on the test because of that, but like, if F has a sharp point, F doesn't have a slope at the sharp point. Anyways, you need two things. You need to ensure continuity by checking to the left and right of the important x value here. You need to ensure equal slopes, differentiability, a smooth connection. Differentiability implies continuity and a smooth connection everywhere. Now, two things to check, which means this one right here is going to help us with that. And we should have an equation for the slopes of f. Well, it's a piecewise function, so the slopes are going to be piecewise as well. We'll have the slopes of bx squared minus 3, which are 2bx minus 0 because 3 slopes are 0. And then you got a log x, the slopes are going to be a times 1 over x. Cool, and then we just check both sides and both things, f and then f prime, making sure they equal each other. I get b minus 3 equals 0, so b has to equal 3 because the log of 1 is 0. So natural log of 1 is 0 times a is 0, so I get b is 3. And then here I get 2b equals a. Well, if b is 6, b is 3, a is 6. Okay? This is interesting. Let's find the expression for your slopes. I need the slopes of a e to the 4x minus 4. I'm going to O and I that. So I got e to the power and I got 4x minus 4.
Move it over here, but move it so it's.
So I O and I this and I get EA. So there should be an A here, which means an A here. So I'll have 4A e to the 4x minus 4. Slopes of minus 2 are 0, so this is for x is less than 1. And then here, I'll O and I that. B log as the outside, and I got 3x minus 2 for the inside. So B log will be B over.
I don't know what I'm doing.
So the slopes would be 3b over 3x minus 2. Okay. Now if I plug in 1, I get a e to the 0 minus 2 equals b log 1. So I get a minus 2 equals 0. I get a equals 2. If I plug in 1 to both of these here, I get 4a e to the 0 equals 3b. I get 4a equals 3b. I know what a is. So b is 8 thirds. All right, done with unit 2. On to unit 3, function analysis. All right, how's it going? What are things increasing and decreasing? We need to do a function analysis, a sign analysis of our derivative. So let's go ahead and take the derivative using the product rule. And we'll set that equal to 0. Now, here's the key. You will be told that you're only allowed to plug in positive values because you're using the log function. You're not allowed to plug in 0. You have to plug in positive values. And we don't factor. We're not going to factor for these equations. Something we're always used to doing. All of a sudden, we don't do. We just solve normally. And we have to know that you use e to a power to solve equations with e's, with logs. And we get this x value, e to the negative first, which is the same as 1 over e. Now the question becomes like, how do I test some points? Well, some points we could test are not like the same as the points that we usually test. We like to plug in whole numbers usually that are easy to work with. But my derivative in its most simplest form, which is this, has the natural log function in it. This is why we choose e to powers. Like e to the negative third is 1 over e cubed. It's between 0 and e to the negative first. E to the fourth is an easy test point to plug in. But you got to make sure you do it and do it correctly. If I plug in e to the negative third, I get this value 2, which means I get these positive slopes. If I plug in e to the fourth, I get -5, which means I get these negative slopes. When is the function increasing? When the derivative is positive. The derivative is positive. The derivative is positive from 0 to e to the negative first. I'm going to graph that because I want to. Negative x log x. Yeah, look at that. Boom. We increase until this value, and then we just start decreasing. And that's 1 over e. Bam. Cool. Next one is fx over x decreasing. Okay, so same deal. Do a first derivative sign analysis. Slopes of the top times the bottom minus slopes of the bottom times the top, all over bottom squared. I'm going to simplify that to be 1 minus log x over x squared. You need to figure out when the top and the bottom are equal to 0 whenever I have a fraction. But I realize that it's not necessary because I'm starting at 0. So the bottom will equal 0 at 0, but I'm starting at 0, so I'm only talking about positive x's. So essentially we know that the bottom is always positive, and we don't really have to worry about it because it's x squared. Now the top set equal to 0, we have to solve. So let me give myself some space. Top set equal to 0. You solve not by factoring, but by actually solving. And you get x equals e. Cool. Now let's use some test points. Here's an opportunity where you could use a 0.1 if you want to, but you could also use e to the negative first. You could use e cubed. If I plugged in e to the negative first, I get 1 minus ln e to the negative first over a positive value. So that's 1 minus -1. So that's going to be positive 2 over a positive value. There's going to be positives here. If you plug in e cubed, you get 1 minus the ln of e cubed over something positive. The natural log of e cubed is 3, so that's 1 minus 3. That's going to be a negative. We are decreasing for all x's bigger than e to infinity, because that's when f prime is negative. F decreases. Okay, increasing concave down. First derivative analysis. Should use the chain rule for it. We did this earlier, actually. we get log x over x. We'll set that equal to 0. Again, we don't have to worry about the bottom equaling 0 because you get x equals 0. We do have to worry about what does log x equal 0. You should know this, but if you're not sure, you get that x equals e to the 0, which is 1. So 1 is our important port. We can use test points like e to the negative second, e cubed. So we have this guy. Oh, shit. So we got this guy. We're talking about positive x's. So if I plug in e to the negative second, the bottom is positive. This is very important. The bottom's positive. E to the negative second is the same as 1 over e squared. It's the top that is negative, -2. So I'm going to get negatives here. And if I plug in e cubed, I obviously see it's going to be a positive over a positive, which is a positive. All right, so we're increasing for x is bigger than 1. Now, for this guy, we did it up above. Maybe do it again. You get 1 minus log x over x, and you get x equals e. And we already did this analysis earlier. And I would advise you try it again. This should be x squared. You would also get, if you plug in something like 1, positive, you'd actually get positives and then negatives. Cool, which means f prime is increasing, decreasing, which means f is concave up, concave down. This is E. And increasing concave down. This is for x is bigger than E. Should have asked increasing concave up. Let's see, 1/2 log x squared. Sick. Okay, decreasing concave up until here. We hit a minimum there. Until E, we are increasing concave up barely, but we are increasing concave up until E, and then we start increasing concave down after E. That's pretty cool. It's really cool. And then we switch to you can see it more clearly that we're concave down, but we do go from concave up to concave down. That's really nice. It's good stuff there. All right, just letting you know to skip this one. And if you don't skip it, here's the answer. I'm not going to talk about it. I already give you f prime. So this equals 0. At 4. If I plug in, I mean, that's like tricky. If I plug in something large, we'd get positives. If I plug in something smaller, like, oh, this is for x is bigger than 3. Yeah, just skip this, man. Just skip it. Just skip it. Sorry. But It's not a good question. I remember this. X is bigger than 4, the answer. But like, not the great question, so we skip. All right, cool. Finishing up with some table problems. Log f of x being the most important one. O and I. Log outside f of x inside. 1 over f prime of x. What does that make g prime? F prime can go up top. F prime of x over what started in the parentheses f of x. It's really cool. It's like the slope over the y value. G prime of 1. F prime of 1 is negative 1. F of 1 is 3. This is an OMI. Log parentheses f parentheses x squared. 1 over f prime to x. Gosh, it's nice out. It was so humid earlier, and now the breeze is rolling in. Feeling good. Okay, if you want to multiply it all together, you have 1 over times f prime of x squared times 2x. Which means the 2x and the f prime of x squared goes up top, while the f of x squared goes on the bottom. What starts in the parentheses stays in the parentheses. You got to remember this. What started in the f was the x squared. What started in the f stays in the f. It's the x squared. What started in the log stays in there, which was the f of x squared. So that's why I got f of x squared. Plug in 1 and I get 2 f prime of 1, just lucky, f of 1. So it's negative 2/3. Then finishing up with a product rule and a quotient rule. So let's finish strong. Slopes of the first times the second plus the slopes of the second times the first. Plugging in E. F prime of E is negative 3. Log E is 1. 1 over E. F of E is 2. And, you know, you get this answer, which is fine. Maybe if you wanted to simplify this, you turn this into 1 fraction. And something you might have to do. Multiply the top and bottom by E. You get h prime of E equals negative 3E plus 2 over E. Slopes of the top times the bottom minus the slopes of the bottom times the top, all over bottom squared. At E, 1 over E. F of E is 2. F prime of E is negative 3. The log of E is 1. F of E is 2 squared, which is 4. 2 over E plus 3 over 4. Usually don't like fractions inside of fractions. Multiply everything in the top by E, multiply everything in the bottom by E, and you would get 2 plus 3E over 4E. Maybe this is what the answer we're looking for is. All right, don't want you to be too intimidated. Like, you should understand all the concepts behind this stuff. However, what's new is like, yeah, we got logs, And everybody is intimidated by logs, but it's what undoes an exponent. And we're just reviewing a bunch of stuff, including logarithms, which you've been introduced to a lot in pre-calculus and stuff. So that's it. Hope you guys had a good weekend. See you out there. Peace.